everyone, we're going to identify and graph the polar equation r equals 1 minus 3 cosine of theta. So the first thing we want to do is test for symmetry. This is going to be a Limacon with an inner loop. I will show you that form in just a moment. Let's first test for this. We want to test for symmetry to make the graphing easier. So for the polar axis, we're going to write r equals 1 minus 3 cosine, and we're going to replace theta with negative theta. Now, if we get back to our original equation, then it is going to be symmetric to the polar axis. Since cosine is an even function, we could just make that a positive. So this test passes, and our graph is going to be symmetric to the polar axis. So let's try our symmetry with respect to the line theta equals pi divided by 2, which is the y-axis. In this case, we're going to substitute in, for theta, we're going to substitute pi minus theta. So we're going to get r equals 1 minus 3 cosine of pi minus theta. We use our difference formula here to expand it and evaluate. So we're going to get this equals 1 minus 3 times cosine of pi times cosine of theta plus sine of pi times sine of theta. Now sine of pi is 0. So this is just going to be plus 0. Cosine of pi is negative 1. And when you have these two negatives here, this is going to end up being 1 plus 3 cosine of theta. These two equations are not equivalent, so this test fails. It's not going to be symmetric to the line theta equals pi divided by 2. Now, the symmetry with respect to the pole means you're just going to substitute your r with negative r. And clearly that's not an equivalent equation. The only time that would be an equivalent equation is if r was squared. Okay, so this is, I said before, a Limacon with an inner loop. And the reason it is we're going to let A is R1 and B is R3. And since B is greater than A, because 3 is greater than 1, then it's going to be something like this. If these numbers were switched, it would be a Limacon without an inner loop, if A was greater than B. Now, in our case, our symmetry is with the polar axis. So this one here that they have shown is with respect to the line y, theta equals pi divided by 2. So ours is going to be turned around a little bit. So let's start with that. We're going to assign values of theta from 0 to pi, and then just get the upper half of our graph and then graph the lower half. So substituting that in, we're going to evaluate our angle in here, and this is going to give us negative 2. I have these written down. 1 minus 3 square root of 3 divided by 2. This is approximately negative 1.6. At pi divided by 3, we get negative 1/2. Pi divided by 2 is 1. 2 pi divided by 3 is 5/2. And 5 pi divided by 6 is going to be 1 plus 3 square root of 3 divided by 2, and that's approximately 3.6, and at pi we're at 4. All right, so let's plot these points, and then we'll use our symmetry to graph the other half of our Limacon. So at 0 we have negative 2. Here's your angle 0. Negative 2 means we're out here. At pi divided by 6, we're at negative 1.6. So somewhere in here. All right. And at pi divided by 3, we're at negative 1/2. So that's in here somewhere. All right, so this is where it's going. Now, at, let's see, what do we have next? Pi divided by 2, we're at 1. So it's coming up through here. All right. And then at 2 pi divided by 3, we're at 2.5. 2.5 is in here. And at 5 pi divided by 6, we're at 3.6. So that's going to be 1, 2, 3, close to 4. So swinging around up some more. And at pi, we're at 4. So 1, 2, 3, 4. All right. So there's half of it. Now to get the other half, we're just going to look at this lower part in here. These angles down in here. So I just match it up. We can look at 7 pi divided by 6. That matches this one. So that will be at 3.6. 1, 2, 3.6. All right. At 4 pi divided by 3, that matches this one. So that's going to be 2.5. Just swinging around here. At 3 pi divided by 2, that's going to be at 1. I'm just matching these up. At 5 pi divided by 3, it's going to be negative 1/2. So we're going up here to negative 1/2. 11 pi over 6, that matches up to this one. It's negative 1.6. And then we're back to negative 2 for 0. So there's your Limacon with the inner loop. So it's just going like this. Trying to make it all one color. And there you have it. Thank you. Have a nice day. Bye-bye.